Hi, my Prefer Business Calc students. How are you doing? Sorry this is taking me so long. I would like to say it was an internet issue, a computer issue. No, it's a mental issue. I don't think I'm alone in this. I am really struggling to get anything done. Like, no motivation at all. Anyway, we're going to do this. I miss you. Okay. So the problems that I put on CourseWeb for annuities, I looked at them. First of all, there's the same problem on there twice. And they're just not very good problems. So I'm going to show you and explain this because it just makes so much more sense if someone explains it. So just to refresh your memories, this is our formula. Annuities, this is money that's getting deposited at the same time in this case, I'm using months. Okay, we're just going to use months from here on out because that'll make that easier, okay? So at the end of every month, say you get paid once a month, you take a chunk of money and you just keep putting it religiously in the same account that has a steady interest rate. How much money do you have at the end? The amount at the end is our A. R is not the rate. R is the amount of money that we're depositing every month. That's a 1. I is the interest rate divided by the number of times you deposit in a year. In this case, that would be 12. Okay? N is the total number of deposits. So it would be 12 deposits a year times how many ever years we're doing. That's another 1. And then this I is the same as that I. Okay, so our first example, what we're going to do here is I'm going to see what difference does it make if you just up that amount of your monthly deposit by, I don't know, say $15, okay? Give up a couple lattes in a month, and you got that much. Okay, so our example here, $25 at the end of every month is going into an account that's getting annual percentage rate of 5.1%. We're going to do that for 20 years. I want to see how much money I'm going to have at the end, and then I want to see how much total interest I earned. So first let's do this part. This is just simply using this. So the amount at the end is going to be $25 deposit. Then we have 1 plus our I is 0.051. We're doing monthly, so divided by 12. So 0.051 divided by 12. And then my N is 12 months in a year for 20 years. So that's the total number of deposits. Minus 1. And then over this 0.051 over 12. I told you guys, I never make this big enough. Okay. The easiest thing I think to do is to take this and figure out what that is. So 0.051 divided by 12. And more than likely your calculator is going to give it in scientific notation, which is confusing as hell. So then go ahead and add the 1 to it. Okay, so this value here, so we got our $25, okay, and then this is 1.00425. 12 times 20, that's 240. That's an exponent. Minus 1. And then down here is the same as this calculation, but without the 1. So it's just the 0.00425. Okay, so I have this. I'm going to take that to the 240th power. Subtract 1 from it. Divide by 0.00425. And multiply by $25. So at the end of this, I'm going to have $10,395. If you want to see if that makes any kind of sense at all, think if you were putting $25 a month away for 20 years. Okay, so 12 times 20. 240 deposits times 25. You would be depositing $6,000, but you're getting interest on it, so it's going to be worth more than the $6,000. Which brings me to this part. If I take my ending balance here, $10,395, and subtract my deposits. Okay, so these are the total deposits. Okay? So I take my ending balance minus how much money I actually put in. The rest of it is what the bank gave me, free money. So that's pretty good. So let's write this over here. So with a $25 amount, our ending balance is $10,395, and our interest is $43.95. Now let's take a look at this and say we change it to 40. This will be example 2. Okay? So let's change that to a $40 amount. Okay, so the only thing that's going to change in this is that monthly deposit. Let's see how much difference $15 more a month is going to make. So we change that to a 40. Change this to a 40. Okay, so same interest rate, doing it every month, 20 years. So with 1.00425 to the 240th power minus 1 divided by 0.00425 times $40, I'm going to have 16,633. Not too shabby, right? That's a pretty significant difference for just $15 more a month, which, you know, depending on your circumstances, you may or may not even feel that. Okay, so to figure out how much interest, I take my ending balance, my $16,633, and subtract my deposits. My deposits are $40, 240 times, okay? The 240 months, I make a deposit of $40, so I'm depositing $9,600. Um, 16 minus 9 is 7. There's our free money. So just by that little bit of an increase in deposits, look how much more free money I got. Okay, so can you imagine if I put $100 a month away? It really makes a big difference. You want to make a commitment, but you don't want to make yourself cash poor. You know, it's easy, you know, on paper to say, I'm going to put this amount away. Well, guess what? You have to buy tires, or, you know, your winter coat is out of style, you want to get a new coat, or you start dating somebody and you start wanting to go out to eat more. Like, pretend like that's like a thing still, or you could go to a restaurant. Anyway, so you don't want to be overly ambitious to the point where you're not going to be able to stick with the commitment that you made to yourself that you would put away. You can also choose different accounts. Make one low, $20 a month, you promise, okay? And then open up a separate account and say, I'm going to put in whatever I can. And then try and, you know, say, okay, minimum $5. Maybe you can put away $100, whatever it ends up being. But you always do the one that you're committed to first, okay? So you don't let yourself down. So really, annuities are much easier than those problems. I don't know what I was saying. Those are old problems because I'm using my old computer. And so there you have it. Okay, so just moving on with this same formula, depending on what is being asked of you. So, do example number 3. Okay, let's say that you're saving up for down payment on a car. Let's say you don't have a car right now that you could trade in and get anything, okay? And let's say, just for the sake of discussion, that you're working and you can afford to put, say, $100 a month away, okay? So we want to know how long how long to have, let's say $8,500. The $100 a month deposit at APR of, say, 4.8%. That give me enough information? Okay, so monthly, so I'm going to be taking 0.048 divided by 12. That'll give me my I. And I'm going to be looking for part of that N because I'm saying how long. So how many months is it going to take until I have 8,500? So my ending amount is going to be 8,500 with my monthly deposit of $100, 0.048 over 12 to the N minus 1 over 0.048 over 12. Did it again. What the hell? Okay. So the first thing I'm going to do is divide both sides by 100. Okay. You don't have to do that first. It doesn't really matter. Okay, so 8,500 divided by 100 is 85. Then I'll do this. 0.048 plus 1. Oops. 0.048 divided by 12 plus 1. Okay, so it's 1.004 to the N minus 1 over 0.004. Alright, so just going to start chipping away until I can get this to be by itself, and then I'll do the natural log thing and bring the N down. So multiply both sides by 0.004. So 0.34 equals 1.004 to the nth power minus 1. So then you just add 1 to both sides. So 1.34 equals 1.004 to the N. I'll come up here now. Okay, got to get the N out of that funky position. Take the natural log of both sides. So the natural log of 1.34 equals the natural log of 1.004 to the nth. I'll write it this way. Okay, 1.34. Bring the N out front, remember? ln 1.004. Then divide both sides by the natural log of 1.004. Okay, 73.31 equals N. So that is going to be 73.3, we'll say, months. If you want to, you can divide by 12, and you'll get 6.1 years. Either one. To check and see if this makes sense, if I were taking $100 a month and sticking it under my mattress, so not getting any interest, how long would it take me until I have $8,500? Well, it would take me 85 months of putting $100 in there. Well, I am getting some interest, so I should expect this to be fewer than 85 months. Does that make sense? I hope. Okay. All right, so example number 4. Okay, suppose I want to know how much do I have to put away at the end of every month to reach a goal. Okay, so how much money every month to have, say, $10,000. I'm going to put down a pretty good chunk on a car, okay? To have $10,000, at APR equals say 6.2%. Okay, And I want to accomplish this in, say, 3 years, which is 36 months. Okay, so just using our formula here, A is the ending amount, that's our 10,000. Beginning amount, I don't know. That's what I'm trying to find. Okay, then I have 1 plus 0.062 over 12 to the 36, total number of deposits, minus 1 over 0.062 divided by 12. Okay, I'm going to start here. 0.062 divided by 12 equals plus 1 equals. Right, so you have your 10,000 equals R times 1.00517 to the 36 minus 1 over 0.00517. Okay, so to the 36 minus 1 divided by 0.00517. Okay, so we have 10,000. And 39.43. Okay, and I'm solving for R, my monthly deposit. So divide both sides by 39.43. And I get 254. I'll just round up. To see if this makes sense, okay, if you deposit, let's just say you took $254 every month and stuck it under your mattress, okay, for 36 months, how much would you have? So 254 times 36, you would have 9,144. You are getting interest, so it's going to be more. Hopefully that makes sense. Okay, let's do this problem. Suppose you graduate from college. Keep in mind there's only a handful of times, well, less than a handful of times that you get a windfall of cash in your life. High school graduation, college graduation, and your first wedding. Because second wedding, people are like, yeah, well, whatever. So you want to make sure you make use of that money. So let's say this is the case. You graduate from college, and you get a lot of gifts and things like that. And let's say you get $1,500 in gifts. This will be example number 5. Okay. So you get $1,500 in gifts. Okay? And say you get a job, you had this awesome internship, and then they hired you right after graduation, so you're making some bank. You're going to put some money away. So you're going to put $250 every month. Is, let's see, 7.4%. We'll say compounded monthly. Right. That's a W. Okay. All right, so here's the situation, right? We have $1,500 in gifts from graduation that you're just going to put in an account and let it grow. Okay. And then you're going to put $250 away at the end of every month for 4 years. Combined, how much money are you going to have when your parents kick you out of the house? Okay, so these are two separate calculations. This one is a lump deposit. I don't know who's calling me, but okay. This is a lump deposit, so this is going to be this thing. Oh, sorry, compounded monthly. That's going to be it all. Okay, this is our compounded monthly for this. So in 4 years' time, how much is that worth? Then we're going to use this calculation for that periodic deposit, okay? Lump sum deposit and leave it alone. Periodic regular deposit. Then we're just going to add them together. Okay, so for the first part, my A after 4 years, if I take $1,500 and plop it into the bank, interest rate's going to be the same for both. Okay, just keep it simple. It's compounded monthly, so divided by 12. And then that's 12 times 4. Okay, so that's 48 months. So 0.074 divided by 12 plus 1 to the 48 times 1,500. Okay. Write this over here. So our 1,500 is now worth that. Okay? Now, the second part of the problem is our $250 a month, blah, blah, blah. So that's this thing. So A is equal to 250. Okay, and my N is going to be 48, because 4 years of making those deposits. At least I'm consistent. Okay. All right. 0.074 divided by 12 plus 1 to the 48th power minus 1 divided by 0.074 parenthesis times 250. And that's going to give me this amount. Okay, now before we go any further, stop and see if it makes sense, okay? I'm putting $1,500 away and not touching it and letting it grow. So this ending balance should be bigger than 15.